Imagine a world where every single app in your company needs to talk to every other app. You start with a simple link between a front-end server and a metrics dashboard. It's clean, it's fast, and it works. But as your business grows, you add a database, then a marketing tool, then a machine learning model. Suddenly, you aren't looking at a system anymore. You are looking at a plate of digital spaghetti. This tangled mess of direct connections is brittle, impossible to maintain, and a nightmare to scale because every new system requires 5 new custom integrations. Welcome to Topictrick, where we turn complex topics into simple, easy-to-understand ideas. If you enjoyed this video, don't forget to subscribe to our channel for more clear and helpful explanations. Now, let's get back to Kafka. Building on that foundation of chaos, we find the solution in Apache Kafka, the central hub that turns this mess into a streamlined data backbone. Instead of a spider web of lines, every producer of data, like your website logs or mobile app, sends its information to one central place. Think of it like a massive high-speed postal service, where the senders don't need to know who is receiving the mail, and the recipients don't need to know exactly where it came from. This decoupling is what allows your infrastructure to grow without breaking under its own weight. To understand how this central hub operates, we have to look at the core concepts of messages and topics. In the Kafka world, every piece of data is a message, often a simple key-value pair. These messages are organized into topics, which you can think of as folders in a filing cabinet. For example, in a banking app, one topic might be successful payments, while another is login attempts. Producers write to these topics, and consumers read from them, ensuring that the right data always gets to the right destination in real time. A perfect example of this in action is the way Kafka handles parallelism and scale through partitions. If a single topic becomes too massive, Kafka splits it into ordered logs called partitions. This allows multiple servers to handle the load simultaneously, much like how a grocery store opens more checkout lanes when the line gets too long. Because these partitions are distributed across a cluster of brokers, which are just the individual servers running Kafka, the system can handle billions of messages per day without breaking a sweat. Durability is the structural steel of this architecture, ensuring that your data isn't lost if a server goes down. Kafka doesn't just pass messages, it stores them on disk and replicates them across multiple brokers. If the leader broker for a partition fails, a follower instantly takes its place. This is why giant platforms like LinkedIn and Netflix trust Kafka. It's designed to be fault-tolerant from the ground up, making data loss a relic of the past. Beyond the core cluster, the Kafka ecosystem extends its power through tools like Kafka Connect and Kafka Streams. Kafka Connect acts as a bridge, automatically moving data between Kafka and external systems like MySQL databases or cloud storage. Meanwhile, Kafka Streams allows you to process that data as it flies by, filtering, transforming, or aggregating information in milliseconds. It's the difference between looking at a static report at the end of the day and watching your business move in real time. As we look at the complete ecosystem, including the schema registry that keeps your data formats consistent, it becomes clear why Kafka is the gold standard for modern data engineering. You've moved from a fragile, tangled web of spaghetti code to a robust, scalable architecture that can support any level of growth. If you're ready to start building your own real-time data pipelines, make sure to check the resources below for a deep dive into the technical setup. Don't forget to subscribe to Topictrick for more architectural deep dives, and let me know in the comments which part of your current system is feeling the most like spaghetti code.